Let's see how our answer to the question of how many ice cream cones we should optimally consume changes when we move from a increasing marginal cost to a constant marginal cost of ice cream cones. So we start with our two-dimensional graph where we have the number of ice cream cones on the x-axis, and then the y-axis captures both the marginal benefit of each ice cream cone and the marginal cost of an ice cream cone. Marginal benefit's going to be a downward sloping line, and the reason it's sloping downward is to represent diminishing marginal benefit, right? So in other words, every ice cream cone we consume gives us less benefit than the one before, right? And eventually when we get to the fourth ice cream cone out here, we're sort of neutral between eating it and not eating it. We get zero marginal benefit. And then if we continue on to a fifth ice cream cone, we actually get negative marginal benefit from it. In other words, you can think of that as the fifth ice cream cone actually giving you a stomach ache and making you sick. We've been treating the marginal cost of ice cream as being an increasing marginal cost. And the reason it's increasing is because it takes into account not just the explicit cost of an ice cream cone, that is perhaps the dollar it costs to buy the cone, but also the opportunity cost or the implicit cost of buying that ice cream cone. That is the value you place on the vegetables you could not consume because you spent the money on ice cream cones instead. Through marginal analysis, we determine how many ice cream cones we should consume to make ourselves best off given our scarce resources by setting marginal cost equal to marginal benefit. And that happens on our graph right here. Okay, so this tells us that we should spend, I'll call it C for cones, C1 star, ice cream cones. Now, how does our answer, that is, how does C1 star change if we instead use a constant marginal cost? So we consider only the explicit cost of an ice cream cone, so that $1 that it costs to purchase an ice cream cone, and we ignore the opportunity cost. So our marginal cost curve is therefore a flat line. So here's our constant marginal cost line. Okay, and similarly, we're going to decide the optimal number of ice cream cones to consume by setting marginal cost, in this case our constant marginal cost, equal to marginal benefit. So that's going to happen right here. I'll call that C star 2. So here's the optimal number of ice cream cones for us to consume when we ignore the opportunity cost of consuming ice cream cones and consider only the explicit or the sticker price. That is when we use a constant marginal cost. Okay, so clearly if we ignore opportunity cost, we're going to end up spending more of our resources on ice cream cones and less on vegetables. And in fact, this is going to make us worse off than we could be because we're ignoring or missing out on the value we place on those vegetables we no longer can afford. In fact, if you consider all the ice cream cones consumed between C1 and C2, we note that the true marginal cost, that is the marginal cost curve that considers both explicit and implicit costs, exceeds the marginal benefit curve for all of these ice cream cones right here between C1 and C2. And so we're being irrational by consuming ice cream cones when they cost us more than we benefit from consuming them.